We are Eva Di Trocchio and Riccardo Dodic from Valles School of Architecture in Barcelona, Spain. Designing our project, we focused on 3 different strategic levels. The first one are the bioclimatic strategies, which means using natural resources to provide cooling, such as the wind through the use of the wind tower, water to design a fresh and attractive public space, and vegetation to provide shade and visual comfort. The architectural strategies are the reinterpretation of the historical city for themes such as the compactness, the opacity of the volumes, the backwards windows, and the narrow streets. The patio, which has an important role as in regulating the temperature of the building, and the souk, from the idea of shading the commercial street. The technological strategies are the ventilated facade to provide cooling through the ventilation, the solar chimney, which enhances this effect by creating an air suction that accelerates the air, and photovoltaic panels to use the inexhaustible energy of the sun. Our project is called Oasis because we integrated vegetation and water to create an habitable space for human beings outside as well as inside. The concept revolves around 6 main themes. The wind, we place 2 rows of buildings in the direction of the main wind direction, which are the northwest and the marine breeze. The water collected from the canal to create the public space, and the vegetation to provide shade and visual comfort. The relationship with the library, with this scenic perspective upper towards it, and the commercial axis designed as an Arabic souk, and in the end the terraced volumes to recreate the complexity of the historical city. This is the master plan of the project. A general view, a photo montage of the pedestrian walkways, and in this view you can see as the mangrove forest provides shade to the public area. Mangroves are allophytic plants, which means they can grow in salty water. This means that they don't need irrigation, which is a crucial theme in a city as Dubai. And as a plus, they can absorb 5 times more CO2 than normal plants. For the shopping street, we decided to build it underground to take advantage of the thermal inertia of the ground, and the shops alternates with voids to provide an expandability as well. This is a photo montage of the commercial street, a general section. These plans are to demonstrate that both the orientation of the buildings are designed to catch the main winds. In this bioclimatic section, you can see how the wind tower, which is the emerging landmark, reaches the maximum construction height of 45 meters to channel air at a lower temperature, higher speed, and with less dust. The air goes inside the patio, where it is refreshed thanks to a fountain and purified thanks to the plants. The cold air is then introduced into the apartment through the inner windows and through a ventilated floor, while the hot air is then expelled inside the ventilated facade, and this effect is enhanced by the presence of the solar chimney, which accelerates the air, creating an air suction. In these plans, you can see how we place the wind tower and the vertical connection core in the middle of the patio, integrated. And the access to the apartments is given through footbridges, and this distance provides as well insulation for from the noise of the elevator for a better acoustic comfort. In these plans, you can see how the depth of the facade is designed to keep the windows shaded from the sun, and in this space we also place the furnitures. These are the facades. This is a facade view in which you can see the Arabic patterned blinds, an upward view of the patio, some references, and a detailed section of a balcony. in which you can see we placed 20 centimeters of isover glass full insulation. Then there is the air chamber and an external reflective white finish, while for the glass doors we use Saint-Gobain cool light glass. This is an estimation of the energetic demand of a building type, and we can produce 100% of the demand of electricity with 365 square meters of solar panels placed on the roofs and the wind tower as well. This is a calculation made with the balance software of the temperature both in summer and winter, and we achieved a -5 degrees during summer in the most unfavorable case without air conditioning. Thank you for your attention.